2 runs. But this is the one which I wanted to do. So for that purpose, I am going to do a Placket Burman design. In this particular design, what will happen? I will study among all the 4 excipient. I pick up the one best one which is having a highest disintegrating effect. I will take that. All 4 are compatible with my drug, but one is having a highest disintegration with that particular drug and resolution with that particular drug. I am picking up. And the next step is, after picking that particular excipient, I need to see what concentration I need to use in my formula. For that purpose, I am taking different levels. That is plus level, minus level, and mid is the 0 level. Like that, we have already discussed. That one part is called as a optimization. After optimization, I am arriving at a formulation which is yielding the whatever I am aiming at. It is okay. Otherwise, I will do the prediction with the equations what I am going to get, and there is the equation yielding me the better formula. That predicted formula I am preparing in the laboratory and checking the result whether it is yielding or not. Then I will finalize that formula. That formula, once it is finalized, I will give to the production to produce regularly. In the Placket Burman design, we have already discussed that you will be having total number of runs which are equal to n plus 1. That n plus 1 is in the multiples of the 4. That means 4, 8, 12 experimental runs we are going to have, because this Placket and Burman, both of them, they given some designs. If you see in this particular design, the first row, that is called as a run 1. It is given some of the designation like a plus level and minus level, plus level, like that. For different variables of 7 variables, he has given 8 runs. That means 7 variable n plus 1 is equal to 8. 8 is a multiple of 4. So it is a design, it is fitting into that. Now you may get the question, sir, Placket Burman has given 8 run matrix for the 7 variable. If I am having only 6 variables, then what I need to do? If you have got a 6 variable, in the place of G, what is appearing as a column, you name it as a dummy 1. That variable is a dummy. You don't employ anything, but you are just keeping that particular one without using any excipient there. You don't use plus or minus, nothing. You don't use it and you don't consider. That is called as a dummy variable. Now you may get the another question. Sir, I have got a 9 experiments, 9 variables. So I want to use the Placket Burman design. But Placket Burman design says that you already mentioned that it is having a n plus 1 runs. N plus 1 means I have got a 9 variable means I am going to have a 10 runs. But a 10 run is not a multiple of 4, because 8 is the multiple of 4, that is 4, 8, 12. So 12 is the multiple of 4. So 12 runs I will be getting it. So but I have got a 9 variables, I am getting a 10 runs. But what is the remaining 2? Then you need to use a dummy variable 1, dummy variable 2. So the Placket Burman will give always the first row. Remaining row automatically we can do it by taking the variable whatever the level which is present, you bring that variable from there and pull it out to first, and you prepare a second row by replacing remaining after next to it. I repeat, in the first row you have got 1 plus, 2 minus, 1 plus, minus, 2 plus. What you are doing, you are removing 1 plus from G column and putting in the A. And your remaining columns, whatever which is present in that sequence, you put it there after this plus. So what you are doing, you are taking one variable that is in the run in the last, whatever you are having, you are putting into the A variable, and remaining whatever the sequence which have got a series of levels that you are putting after this, then you are going to get a plus. So this I have brought from the last column, and I am going to bring it again next to that remaining variables. So this is actually the plus. Again it is coming double minus, then plus, 1 plus, and the remaining plus I am putting it. The third run, again I am taking this plus and putting into the first column, and I am getting a triple plus now. After that I have got as usual remaining 2 plus, 1 plus, minus. Again I will bring that minus, I am going to get a fourth run. Again I am going to get a 3 plus. If you repeatedly doing it, and at the 7th run, all the sequence will be completed one time, and the last run will be all are minus values. Sometimes in some designs, you are getting all are in the positive values. So this is actually what the Placket Burman have given. So the column represents the factors, row contains the runs. Two levels are present, that is plus or minus for the screening design. And the first row will be given by the Placket Burman. We can take the remaining runs by taking the last column, whatever the level is present, we put it at the first, remaining we will be filling it automatically. The next row also we are going to do similarly. At the end of the column, the last 8th run is all or minus. I already repeated. Some designs and some experimental softwares, they are using all plus also in the 8th run or 12th run or 16th run. So this sign go across down to the next run and it is going to be repeated. This is actually what the logic of screening design made by the Placket Burman. This is applicable to the number of variables are very high, because if you have got a 12 variables and you have got a 2 levels, L to the power of b is equal to 2 to the power of 12. We have already made it clear that it is appearing around 1000 above experiments. So we want to reduce that particular variables of 11 or 12 to making it to very less number. Then it is very good important, because in the fermentation of the antibiotic coating of the tablets, your variables are very high. You have got a coating solution variables, you have got a thickness variables, you have got a equipment variable, you have got a process variable. All are together, it will be number of variables are very high. In those cases, screening designs are better. It can be applied. If the response is not well defined and we are not going to be taken all, at least we want to get some data of each variable, then this design is better. In the coating process, our machine and our coating solutions are unique. Our viscosity is unique. So we have not defined what is its response. So we are hitting into the dark. In that particular case, take few number of experiments and you conducted a study with less number of experiments. You get the data. The response what you have got, that is either it is a disintegration reducing, or it may be a taste masking effect, or it may be having a sustained release effect. Whatever we are expecting it, that response is known now. You take the remaining experiments in the full factorial design, because you are reducing the number of variables there. But the disadvantage is that we have got two types of effects. One is a main effect, that is binder is interacting with disintegrating agent. Disintegrating agent is interacting with diluent. Such interactions are not known in this particular design. It will not identify any interaction. It will give the only main effect. Main effect means what the binding agent is doing. It is reducing or increasing. What disintegrating agent is doing when compared to another disintegrating agent, whether it is increasing in relative to the another or what. It will tell that only. But what will happen if both are taken together, and why it is either reducing or increasing, or it is actually a symbiotic manner, or it is contradictory, that is antagonistic manner, we don't know. This is actually a basic disadvantage. Why disadvantage is this? We have arrived this particular one because of the number of experiments are less. We have removed so many experiments, so these interactions will not consider there. We are taking only main effects. 11 variables, 12 experiment I am taking it. Only main variables of 11 only I can know. I don't know what is happening with level variable 1 and variable 11 with 9. I don't know. If I want to know that one also, I need to take a full factorial design. So this is actually what we need to see in the full factorial design and fractional factorial design, and how to choose them. And we know that in initial stages we don't have any data. A screening design, that is a fractional factorial design, is good. After the variables are reduced, full factorial design is good. So once the screening is over, we are entering into the optimization. There we are having a response surface designs. These are all very important for your project work. This response surface modeling, generally we use two types of designs. One is a central composite design, another one is a box Behnken design. What these two designs are doing and how we are going to be use them. Not only these two and Placket Burman, we have got so many another varieties also. We are going to see them also. Design. This contains an embedded factorial or fractional factorial with center points. That is augmented with a group of the star points. Now the question comes, what is the center point? I am taking center point is 0. In the Placket Burman design, I did not take any zero. I have taken -1 +1, minus plus minus plus. There is nothing zero in the center. That is mid value. I did not take. Why I have not taken there? If I take the mid value plus -1, 0, +1, there are 3 levels. According to our LV Prasad rule, L to the power of V, levels are 3, variables are 2, 3 square is equal to 9 experiments. Because 9 experiments are too high when compared to 2 experiments, that is 2 levels. 2 to the power of 2 means 4 experiments. 5 experiments are getting increased. So I don't bother there in the screening. At the center midpoint, what is going on? In the extreme, I am taking very low value of disintegrative and very high disintegrating, very low binder and very high binder. What is happening? I should know. Then what will happen? I should not use less than this. I cannot use more than that. I can define it in the screening. But I want to know what is happening at the 0, mid. Mid value means it is in between the -1 and there is a +1. We have got a 0. That is mid value. So the -1 is 10, +1 is 90, mid value is 50. Why? I am adding 40 to 10, I am getting 50. 50 plus 40, I am getting again 90. So that mid value is 40. I don't study in the screening design. But in the central composite design, I am going to study that also. So these always contain the twice as many as the star points as there are the factors in the design. Say for example, you have got 3 factors, then you will be adding a 3 into 2, that is twice, that is 6 star points you are going to get. What is the star points and how it is there? Just I will be explaining in the next slide. The star point represents the new extreme value, low or high. New extreme value. What is the new extreme value? Previously we are defining -1 and +1. That is actually our levels. Now what we are taking new extreme value, I am taking, instead of -1, I will also take -2. And I will take +1, I will take +2. Now my variables are becoming 5. So instead of 2 variables, now my variables are becoming 5 because I am taking the extreme value. What is that extreme value? -2 and +2. In addition to our -1, +1, in between 0. So these extreme value for each factor in the design, now my levels are increasing to 5. Variables are present 3. L to the power of 3, 5 to the power of say variable, whatever you have got, 2 variables, 5 into 2, 5 to the power of 2 is equal to 25 runs I am going to get. So this is actually what this central composite design, it will increase the number of experiments to study the extreme value, because I don't know what is happening if I reduce the further lower, if I am increasing the further lower, and what will happen in the center, I don't know. This is all will be studied in the central composite design. So the picture of central composite design, it must imagine that there are several factors that can vary between the low and higher values. If you see the next diagram, you will come to know. What is the star points, which will be mentioned in the right side of your slide. And there are 3 types of designs are present, types in the central composite design. Central composite design, circumscribed, central composite design inscribed CCI, central composite design inscribed, that is faced. It means I want to go within the parameters what I have already set, or outside the parameters I'm going to around that parameter, inscribed within that, and I want to restrict myself to the face of that particular value. What is this face? Inscribed and circumscribed, you may be getting the problem. The reason is, if you see, in the 2 variables are present, we will be having a x-axis and y-axis. When variables are 2, that is actually called as, just like your graph paper, you can represent it. When 2 variables are present, one is absorbance, another one is concentration. Concentration is on the x-axis, one variable, it is affecting your y variable, that is actually absorbance. If concentration is increasing, absorbance is also increasing. So only one variable and one response you are able to represent in graph paper, which is having a 2 dimensions. Say imagine that you have got a three factors, then you need to have a x-axis, y-axis, z-axis. Because two variables you want to represent and how they are affecting your y, then you are going to have, say for example, you have got a solvent effect also, you have got a concentration effect also. Based on that, you want to study what is your absorbency. In that particular case, your graph paper is not sufficient. You need to have a three-dimensional imaginary paper. You need to have it. If you are seeing that just like a cube, you are seeing in the top. In the two-dimensional, we can represent these star points. If you see here in the center, you have got a 0, and it is coming to the all sides of the square, which is coming +1 and -1. And outside that, you are going beyond your +1 and minus, means either it can be -2, -3, -4, whatever the level you want to go, you can go. That is the reason it is that star point is represented as a -alpha, infinitive. Infinitive level you can make it. So this is actually what you are going to study beyond your limits, what is going on with my variable. And if I am decreasing to lower to the decimal point, I am increasing my level to 100% of what I wanted to keep it, not more than that. Because this is the maximum I can do it. That can increase up to the +alpha, and I can decrease to the decimal to -alpha. Well, I can go like that. So I can study entire picture of that particular variable range, so that I can take the decision in the next time. This is actually what they called as the star points. There are some more there which are presented in the top figure, which is nicely represented. The red colors are represented as the axial points. They are appearing at the axis, and the blue colored one are represented the factorial points. These factorial design, I'm taking a +1 level, -1. These are all the levels, and the center point is 0. That is green, which is presented at the center of cube, and the triangles are the hybrid points. These hybrid points I want to insert in this. Hybrid point I can insert in this design, so to get the value and effect of that in my response. What is the variable I can insert it. There are so many softwares are present. They will ask you how many hybrid points you want me to introduce, how many axial points I wanted to extend. You want to go to even -3, -4 also, or you want to restrict to only -1, -2, and +1, +2 only. It will ask us. If you want to have a number of experiments and I don't have any problem, I can take the alpha value to the -3, -4 also. It will increase the number of experiments very high. So this is actually what I want to restrict myself within that one. Then I will ask this particular triangular point, hybrid points in between my design. If I am putting only phased, so I am taking this hybrid points and axial point and the center point and factorial points within that particular cube only. Within the face of that particular cube, not outside that. I can do that also. And I'm studying within the cube, that is whatever you have got a cube, that is having x-axis, y-axis, z-axis, all are having a equal height. That is either +1 or -1 or +2 or -2 equal. That is actually a cube you are going to get. So this picture entire thing I am going to get within the face, within the cube, and outside the cube. Circumscribed. Outside the cube also I can study. This is, it may be confusing to you, sir, what it is going beyond my head. How to make myself to clear. You don't have any live example now. That is the reason you don't know. Say for example, I will give you one point. You want to use controlling your release. You want to use 10% of binder concentration. 10% of binder concentration. But your actual concentration of the binder required is 50. You are using 10. So it is the 10 means your highest value is 10, the least value is 0. So your 0 is -1, and 10 is the +1, and 5 is the mid value. You are keep on studying in this only. Then what will happen at particular point of time? You will feel that there is no control with this particular binder. I cannot use this binder. I need to change another binder. You already studied. You found it suitable because it is compatible, and you have taken the experiments also screening. It is proven to be the best, but your range what you have used, it is not yielding good result and you are dropping it. It is worst part. But in the central composite design, it will ask us, you want me to the extend outside your range also? Outside the range you want me to study? If you say yes, that will take 20. Now 20 will become minus 2, 0 will become minus, 20 will become plus 2, 0 will become your minus 2. Now 10 is your mid value. Previously it is a 5 is the mid value. Now it is changing it. It is expanding it. If you are putting as a 50, so it is extending from 0 to 50. Now center value is 25. What you are doing in the central composite design, you are keep on extending your star points and you are going to the infinite level. You are reaching even up to 100% what you can use there and you are finding its effect. Then you can take what extent I can use that binder to control my release. Otherwise I will drop it or I will fix a particular concentration. Or I can know that less than this concentration, I cannot work with this compound as a binder or a controlling agent. I need to use minimum of 50%. It means the remaining 50% of my formulation weight is made up of drug and other excipient. Can it be possible for me that 50% of my formulation occupying but binder is costly or it is cheaper or the binder is easily available? Is it possible economically? So I can take a decision here by using this particular design which are circumscribed, inscribed and pasted. Depending upon my requirement, I will be using it. Sometimes what I will be having, sir, I know it, my value of better control is present exactly between 0 to 10. I don't have any doubt that is going beyond 10 and less than 0, it is not possible to use it. So you want to use a phase design. In that particular phase you are giving, within that only it will be studying it. It will ask you, you want me to study at 7, you want me to study at 2, 3, not outside. Previously it is asking you outside. In the phased, it will be within the phase of the particular cube, it will ask you. Inscribed, certain star points you can give it at 1/3 of your level, 1/4 of your level, whatever you want to use it, that can also you can use as a star point within the cube that you can do it. It means that you want to explore all possible options by taking a particular design for your experiment. You feel that the range or the levels what you are going to use is 100% perfect. This is actually what it is providing you an edge that this entire range what I'm going to use, it will be yielding a better result for me. In future, I can use it. And wherever I want to increase, I can increase. Where I want to decrease, the decrease. That can be possible. And I will make my formulation very cheaper also and performing very well. If you see the next design, it is actually called as a box Behnken. This is also similar to the central composite design and it is coming under the response surface only. They do not contain embedded factorial or fractional factorial design. Box Behnken use the just 3 levels of each factor. It will be using only 3 levels of the each factor. That is -1, -1, -1, 2, minus plus, -1 plus -1. If you see the extremes, it is giving something which is present extreme side which is having plus 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 highest level. Within that only it will study. Within that sphere or the circle only. If you draw the circle, it will be taking as a boundary. It means you are putting one kettle in a center, you are putting one rod and you are tying with a thread. So the thread is having some length, radius. If you are allowing to touch your grassland only to eaten by the kettle, you are putting that particular length only, that thread. Then what will happen? The kettle will be moving in your land only. It will not go outside land because otherwise they beat and your kettle may die. Then what will happen in the box Behnken design? You will make it completely a circle. You don't want to go beyond that. If it is I'm touching outside it, I'm going to have a problem in my stability. I'm going to have the problem. I don't want to go in. In that particular case, box Behnken is better because you have already proved that this is my range. I'm going to work not outside that. In that particular case, you may get the question now, sir, I can do the same thing in the central composite also. Yes, you can do it by taking in a phased and inscribed design. In the central composite also, you can do it. There is no other issue. So you can use the box Behnken also, but central composite also. So box Behnken designs are just 3 levels each factor. Here you have got each factor at the 3 levels. That is in the center 0, -1 and +1. But in the central composite design you have got alpha also. Minus alpha, minus plus alpha means you can go to -2, -3, -4 or +2, +3, +4 also in addition to your -1 and +1. So in the 3-dimensional factors of ABC, that is A is x-axis, factor B is y-axis, factor C is z-axis. So these factors for the 3 factors are circled points appearing at the origin and probably repeated several times, and you will be having a confidence that when I am repeating the same experiment with a 0 level or particular level, what is happening to my response? Because it is repeated severally, your confidence will be very high. Because of that reason, in these 2 designs, your number of experiments are very high. You should never tie these experiments and these designs, because when your variables are too high, your variables are less than 4, preferably 2 or 3, these designs are excellent. If you are increasing your levels more than 4, you are studying this, your number of runs will go beyond 100. It is out of control and highly time consuming. What is the experimental strategy you are going to have it? Most of the times the response surface methodology, I'm telling always, what is this response surface? What is giving a response on the surface of method I'm using it? I know that the variables are present x1, x2, x3, xk, that is n variable, that is the 3 or 4 or 7, 10, 12 variable. K is equal to number of variables. Is a function of one dependent variable, that is y. So y is function of I number of variables, that I can be 1, 3, 2, 3, 4, 5, whatever it may be. Now, if the I is more than 4, I am using screening. If I is less than 4, I am going to use a optimization design, that is box Behnken or central composite design. So accordingly, my y is the response is function of n number of variables, that is x1, x2, x3, x4, xn or xk. It is represented as k. Here the response variable is y, that depend on the k number of independent variables. This is actually what I am going to get in the first point in the my DOE and the response surface. The second thing is, after getting it, the factor given are directly estimate the effect and interaction of the model. And as described in the figure previously, what we have seen, because it is having at different levels, it is working, and it will give the interactions also. Because of that, if the factors are unknown, then first calculate them by using the screening method, and you come to this particular design, and you are coming out to arriving at your interactions also. And estimate the interaction effect using a first order model. What is the first order? In that you will never have the squares, x1 square, x1 into x1, like that you don't have in the first order model. In the second order model, you have got x1 square. In the third order model, x1 cube, like that you will be getting it. So you know that in intermediate you are learning binomial reaction, the linear equation, binomial, polynomial. In a linear, you don't have squares, something like that. It is a linear. Y is equal to mx plus c. This is a linear equation. Whereas y is equal to m x square plus xy plus y plus c. Then it is a binomial. There are x square. There are second order is present. You may get the polynomial. Y is equal to x cube plus x square plus x plus c. Like that you are going to get. If it is for one variable, if you have got x1, x2, x3, imagine how complex that will be. So when the order of reaction, order of model is more and more, you will get more and more responses, more and more interactions and complicated equations you are going to get. This epsilon is indicating that interaction effect in the linear model. And the linear model, you are going to have interaction x1 into x2. You don't have any x1 square like that in the linear. But in the polynomial reaction, you are going to have like this. Constant x1, x2, x1 and x1, x1 square, x2 square, and epsilon. Epsilon means all your interactions. What is the interaction? x1 into x2, x1 square into x, x2 square into x1. So many things which we are going to have an interaction. Like that, you are going to have a second order model. In the second order model, you will get a square, square, square like that. In the third order model, you are going to cube x1 to the power of cube. Now you may get this, sir. How can I know that I am going to get this or not? In the present software, they will ask you whether you want me to give me the equation linear, binomial, polynomial. It will ask you. If you are selecting as a linear, it will give only linear. There is no squares, and I think it will give. If you are giving binomial, it will give only squares, not in the cubes. But the problem is, you don't have much predictions better by don't employing these squares and polynomial equations. When you have got unpredicted results, then you need to employ polynomial function. Then only your predictions are correct. That is the reason. This is actually called as a curvature effect. If the curvature is found in the curvature means linear relationship is not there. Linear relationship means x1 plus x2 plus x1 x2 like that. There is no square like that. So if linear relationships are there, it is having curvy linear relationship. Then what you are employing in your graph log, you are getting again called in a log. In a similar manner here, when you are having a curvilinear relationship, you bound to use polynomial function. Don't ask the software forcibly, you give me linear equation because I am comfortable with that only. Because you don't have the predictions correct. Because ultimately what you are doing, you want to predict something from this particular equation for the run outside your design. But you can't do that by forcing the software. So generally they will suggest recommended is this. Polynomial function is recommended for your particular response. What do you want me to do? It will say the fact that software it will tell recommended is this. So then if you are thinking that I don't want any polynomial equation, I want to only linear equation, you can forcibly ask that to give a only linear. It will give linear equation, but your predictions are not going to be well outside your limit. Within the limit, it will be correct only. But even there also you have got a curvature effect. Your predictions are not good. This is actually what the problem of linear equation when compared to polynomial. That is the reason. In the screening design, we are going to get a linear and most preferably even it is having a curvature effect also. We don't want to find it because of the number of experiments are there. But in the optimization response surface designs, whether it is in box Behnken and central composite designs, it is better to have a polynomial equation C so that your predictions are correct. So making the graph, find out the stationary point, maximum response, minimum response, that is the saddle point by using the obtained value of x1, x2, x3. What is this x1, x2, x3? In this equation, you put your whatever the variable you want to put it. Say, for example, previously you may get the doubt, sir, why it is the beta 0 and beta 1? What are the values? These betas are constants, x1 is the variable. Constant can be either it is 1, 1.2, 3.1, anything which will be coming. B12 may be a 4.2, B11 may be a minus 1.2, these are all the constants. Okay? And x1, x2, x3, x square, these are all the present. So you are going to have those values find out at mid levels. Mid levels means you are studying the point -1, +1. You want to study what will happen at minus 0.5 and plus 0.5. You are not studied, but you want to predict it. In the place of x value, you put that value of minus 0.5. Then you calculate all the equation, you predict the response, what is its y. It will give the what is it disintegrating agent or dissolution time by getting this equation and see that yes, this y is comfortable to me. And I will fix that 0.05 minus 0.05 is the x1 level and x2 level is plus 0.75 is the plus level which is I am going to get it. So that you will be having a y value, whatever which is coming to you is the best suitable to you, that you can predict it. Sometimes you can ask the software, you give me the best maximized response. Maximized response means you want to have highest response in the dissolution for the fast disintegrating tablet, or least response in the friability. You want to have a minimum response. Friability is the least one, is the preferable. So you want to have minimum response for the friability. So what you tell me the variables, what level I need to use it. It will give you the values of x1, x2, x3, x4, and it will give you the whatever your probability or your disintegration or dissolution time, and you are feeling very happy. You prepare one experiment with plus 0.75 and plus 0.5 plus 0.4, whatever it is suggesting it, conducting the laboratory and do the dissolution and disintegration and fiability. If it is working well, fix it. That's it. Your formula is finalized now. It is predicted, it is working in the laboratory, and you are finalizing that formula after optimization. Regulatory body also very happy with you. This is actually what the advantage is. But why we are not going to have a predictions occurring? Why you cannot have the what I'm predicting with the software may not work sometimes because of the variance. What is the variance? Variations in the machine, variations in the method, variations of the man, variations of the material, and variations of the measurement, that is analytical tools. These variations are not incorporated in DOE. Those variations will give you trouble and it will not give the predictions method. That is the reason whenever you want to employ the DOE, don't change your binder, don't change your equipment. You are changing from spray drying to fluid bed drying and asking it to design to do it. Previously you are doing spray drying and you are doing a dissolution, porosity is different, now you are getting a granule size is different and asking the design is not working. Don't change the method variable, don't change the machine bigger to smaller size and dimensions are changed and you should not do it. And the man, a skilled person and the person who is erratic, always not reliable, you are asking him to do it. And material, one is bigger size, another one is a smaller size. These are all the things which you should never change during your experimentations so that you will not have any variations affecting your DOE. Your predictions are going to be correct. But the last M is measurement. Your analytical machines and pH and your balances, everything should be perfect. Then only you are going to get a proper prediction. DOE, you are causing variation by the changing the factors that affect one or more of the 5Ms. Then we statistically break out these effects to determine what variation was caused by which source, whether it is due to the excipient or due to these 5M. This I want to find out. Why this error is coming? For that purpose, we are having some more the tools. What is the tool? It is a general saying that in the statistics, all population is normal distribution. If you take the heights of the people in your class, 14 numbers are there, you take the heights of all students in your class, it will appear as a bell. What is that bell? You will be having highest height persons in your class. Maybe Devipya, like that somebody is having a least height short person may be having somebody. So in that particular case, least and highest person, they are having a low number, but a middle one that is having a highest number in there, like that. So in your class, if you are taking and plotting this curve, you will get a bell-shaped curve that is called as a normal distribution. In the statistical process, if you are taking this particular variation as a bell, and you might have already studied in the statistics, and it is a thumb rule that each statistics you have got a variance around a central value. The central value we are calling it as a mean, and the variation we are calling it as a standard deviation. And it is a general rule in the it is present that if you are having a central value plus or minus 1 standard deviation, it will cover 68.26% of your population. Plus or minus 2 standard deviation, it will cover 95.46% of population. If you are taking the entire median, that is medium value, that is average mean value, plus or minus 3, and you are putting that range it will give you cover the 99.73% of your normal distribution. This variation is inbuilt in the system itself. It is not the variance caused by the 5M. Don't get confused. This is the normal distribution. It is obviously present. You will make the Bruhaspati also working as a machine, and your extraordinary machine you are using in the artificial intelligence. You are using all in the daytime without any environmental character. In spite of that, you will be getting this normal distribution. Then how to find out this variance or the standard deviation is caused by this normal mean or due to something else? This is our question. For that purpose, we need to use the ANOVA. In the ANOVA, it separates the variation to distinguish the what the source it is coming. This is coming between the runs. It is coming between the days where the variance is introduced. It will tell. If that variance is more than your normal variance, which is actually present in the system, like plus or minus 3 standard deviations for the 99.7. If it is beyond that, it is called as a significant different, and you can thought that your Y response is predictive and your model is having an impact. If it is not having that, it is having insignificant effect. We need not have the significance. So based on the fit of these models, the experimental data, you have something you can use or not. You can think that it is not, no need to use that because it is not having a worth. This is actually a DOE and statistic will be going together. And it is very tough you to understand. And that is the reason in the pharmaceutical companies, most of the times, there is a separate statistician. He will be doing all this ANOVA and telling that whether it is significantly different or it is not different. So these are all the things which are present, but you have got a subject in the curriculum. You are going to learn them how to calculate a mean, standard deviation, and percent RSD, analysis of variation, and you are doing a t-test and f-test. These are all we are doing it. And whether the variable which I am using it is causing a response variable due to normal or any excipient I am using, that I can find out by because of these statistics. So there is one is called as a correlation. The correlation is the one which is having a correlation and regulation. In the correlation means when it is having effect increased with the another variable. So one variable increasing, that is absorbance is increasing and concentration is increasing. This is actually called as a linear. Degradation increasing when temperature is increasing. This is linear but a negative response. This is actually called as a linear regression, y is equal to ax plus b. Quadratic regression, that is y is equal to bx c x square, that is binomial. Higher levels also present where you are going to have, in those cases you are going to calculate the error and you are going to have seen that. Just a minute. Hello. ఓకే మీరు తినేయండి, నేను మళ్ళీ చేస్తాను 10 నిమిషాల తర్వాత. Now, so you will be calculating the error by using the deviation of your response with the variable what you are using by using the formula y minus ax minus b whole square, and add all this, you are going to get the error. That error is giving that what you are having a predictions with the regular one what you are going to use it. Find the values that minimize the error. Most of the times you are going to reduce the error. Here we are having a concept called as the Taguchi philosophy. Wherever the error which is assigned with some machine, you want to use it with the strict one. Like I want to bolt it correctly, I want to mop it regularly, I will apply the grease so that I am doing it, error will be less. In the Taguchi philosophy, you are employing not the response, you are taking the error and you are going to find out where you want to reduce it. It means your DOE, statistics, and your error determination, all the three which are giving in common manner and in parallelly, and you take a decisions to reduce the variation or increase the response or fixing our variable and by optimizing it. So this optimize is to find the partial with respect to a set, it equal to a 0, and you want to make it the highest level of one you want to acquire or the minimum level you want to acquire. So you want to optimize it. Why, where you want to have a highest level, you want to maximize. That is in the dissolution for fast designing effort, you require the maximize response in the optimization. In the case of friability, you want to target at the minimize the response so that you will be having a least friability. Depending upon that, you are going to calculate your optimum response with what variable I am going to get it and fix it. For that purpose, you have got two tests. One is a t-test, another one is a test. And t-test is whether the population estimated averages are statistically differences. That is, actually your responses are different at the confidence level. Whereas the f-test, the population estimate variances are, the deviations are statistically differences are not, we are going to tell in the f-test. So if you want to study the differences between your response means, t-test is good. If your response is variances, f-test is different. Where the variance is coming, that is error is coming or the deviation is coming, you want to find out f-test is coming. Variance is coming between the days, between the runs, between the repetitions. So such things variation you want to find out, f-test is better. The variance between the response to one response, which is a pairing, then t-test is better. So when you are having a higher levels where you want to target the variance, we are going to generally use f-test only, ANOVA. T-test, student t-test we are going to have. And you need to see the degrees of freedom. Most of the time, DOS degrees of freedom is depending upon the sample size. Generally, we have got n minus degrees of freedom. This is depending upon your, based on how much variation is present and sample size is present. We are going to take at the degrees of freedom, what is my response is significantly different or not, we need to fix it. So f-test like a t-test in the concept, they calculate the f value from the sample variance. These are all you are going to get in the biostatistics chapter, don't worry. And it will be depth, you will be given solved problems also. Now, what is you need to do is, you take fundamentals in this particular statistics and fundamentals of your DOE and apply these two together, take a decision that I'm going to get a solution with that. But after getting the solution, I'm getting the variable and variance, and my response is not getting repeated most of the times. Then you need to find out the variance and where it is coming, we need to find out and fix that particular one. This is actually what the journey we are going to do in the optimization. This is the reason you have got a lot of headache in the off unit. It has been kept in the curriculum to take this vast topic. It is not possible to control and make it to a small number of classes. It is a bigger one. My appeal to all persons is, there are so many courses are available in NPTEL, and there are some courses which are available free platforms. You just Google it, Coursera or anywhere, and you will be going to get a design of experimentation and statistics tools, f-test and t-test, ANOVA, and you are going to get a variance and Taguchi philosophy. These are all the buzzwords. If you are keeping in the putting in the Google, you will get a free courses which are available. Find a free time, no need to pay anything. If you want to get a certificate, you need to pay, otherwise you learn everything and you say that I will be stopping it. And they will not provide you, but you can access it and you can download the material, everything you can do it. And you may be getting so many doubts, there is no doubt in it, and there are forums are present. You can ask me also where you got stuck up, and if you are doing some courses, you stuck up somewhere also, I can help you. And a little bit if you are doing it, then what will happen, you will get a confidence in executing it. Ultimately, even if you are learning all these things not possible, you need to apply it. That you are going to do in the second year. All these what you have learned, you are going to apply it. It will become your concept form. Then you will be having a little bit lightness, that as I have learned this particular concept. So these degrees of freedom is the number of observations made in the excess of the minimum theoretical necessary to estimate the statistical parameter. So you need to have how many number of theoretical necessary estimate experiment you want to find out. What are the observations which are made access to that. That one is actually called the number of degrees of freedom. And this one, no need to break. Sometimes you have got two variables, n1 and n2. Then it will be little bit complication. And you are going to have only one variable, one number, that is one population only n1. These are all depending upon the how many number of variances you have got, how many number of samples you have got, depending upon it will be deciding. And there is one more constant which is concept which is missing. You will be getting confused. What is this? Is a residual error. What is this error? You are getting DOE The DOE is applied to determine your optimum response. You have predicted one response and you have applied in your lab and you found the actual response. There is a difference is called as an error. This is one type of error what you are using, your error and the deviation from your predictions and actual. There is another error is called as in the design itself, your predictions have got some error. With inbuilt in the equation, it is producing error. The difference between the observed and the model, what you are getting is the model, what you have applied there. So this residual error, if it is lesser, then your equation is excellent. You can use it for the any level, whether it is outside your boundary or within the boundary. That is what you name it is inscribed or phased or subscribed, it will work. If it is not working, your residual error is more, then what will happen? Your predictions are wrong. You cannot relay that model and you need to do again design of experiment and new experiments again. The goal of any model is to minimize the residual error. That simply means that our actual points agree with more closely with our predictions of those points. So, just a minute. There are some more designs are also present which you are going to listen. Is homogeneous fractional factorial design, mixed level fractional design, box hunter and Placket Burman, Taguchi, Latin square. These are all the one which you are going to have even simply Google it also. These are all not only this is homogeneous fractional. In this particular one, you will be having in every software customized, or it is having inbuilt. Customized means you can make the fractional factorial design heterogeneous. Heterogeneous means you don't want to stick to the design what you are putting there in the plus minus and minus like that. You want to apply some custom, whatever you want to make it. It is not having homogeneously in every parameter -1 +1 like that. You want to make it a variations in that also as a custom level that you can also do. In the custom fractional factorial design, you can intentionally stop some runs and you don't want to do it and add some more runs in the custom designs. But generally, I don't want to go beyond the scope and make you confusion. There is one concept called as orthogonality. In the orthogonality, you need to have all the number of variables, whether the plus or minus are equal in all. If you are adding it in all the runs, it should be getting an equal proportion. Both are required to be present, not one-sided. If that orthogonality is not there in the custom designs, your predictions are going to be wrong. So it is better to follow a software and ask the function, and it will be giving that particular design, and you follow the design and proceed with the experiments and conduct the experiment actually and predict with the equation and find out the deviation. If least error is present, residual error is present, go with that particular model and finish your work. And this Taguchi philosophy, what is being given is for to reduce the variance only. What we have seen generally, it is variance maybe with any one of the 5. I want to target it because my response and my drug compatibility is correct, DOE is correct, everything is correct, but my response is not reliable because of the variation. I want to reduce that. What is that variation I'm getting with the men, with the machine, with the methodology, with the environment, what I'm using there, that is depending upon what I'm going to get that variance, I want to reduce it. There, I want to take that particular one as a response and I'm going to study how to minimize the variance. Same as that of your DOE only. Okay, mixed level fractional useful when the variety of the factors are needed to be evaluated for the main effects. Higher level interactions can be assumed to be negligible here. You can, because you are using the mixed level. Box hunter fractional design. It is fractional means you are reducing some of the runs with factors more than 2 levels can be specified as a homogeneous fractional or mixed level factorial. This homogeneous fractional and mixed level means in one factor you are using the -1 +1 0. In another factor you are using the plus -2, -1, 0, +1, +2, like that you are going to use. Placket Burman, we have already seen the factor I have already mentioned. You are going to have n minus, you can have the n experiments with n-1 variable, or you are going to have a number of experiments with multiples of 4. Taguchi, it is similar to the Placket Burman only, but it is a little bit different in the design. It is not same. It will also be a fractional factorial design. It allows the estimation of the main effect while minimizing the variance. Latin square design, they are special case for the fractional factorial design where there is no treatment factor, interest 2 or more blocking factors. What is these blocking factors? You will take all experiments which are conducted in the rainy season in the block, and all the experiments which are conducted in the winter season as one block. This effect we can do. In the lateral square design, you can put all experiments which are done on the male rats. You can put it in one block, female rats in one block. This is actually another block, is a good concept, so that you will be studying the effect of that variation also, which are grouped together as a block. See that how they are behaving with respect to their sex or their season or environment, like that. This is actually a little bit of concept and not possible to be understand. I think you might have already done in the statistics, how this blocking is done. Then you are going to take all the experiment, because they will be in the software. There is an option, it will ask you, you want me to do as the level as a random, you want me random or a particular order, you want me to give the experimental runs. In the random means you can take R1 experiment, R8 experiment in the next. There is nothing that you need to do first experiment R1, R2, R3, R4 and run 8 in the last. This option is already there, but in the grouping you can't do it. You have to do there only, that time only in that combination. This is the one. And I want to recapitulate what we have already done. In the 3 factorial design, we have got 3 level full factorial, you have got -1 and 0 +1. And the 3 levels which you are having it, then it is increasing it, then you reduce the 0 and you will be having a +1 and -1, and you are making it possible to get a less number of experiments. So for that purpose, you have got a concept called as a full factorial design and fractional factorial design. And it is used for the full factorial design for the small number of factors, fractional factorial for the more number of the factors. This is actually what the DOE is. This PowerPoint, it will give you the guide only, and extension will be seen a vast matter